All right, hey guys. Today we're going to do the review for your test. Here's the questions I would recommend in the book. This is in the chapter review section of the book. Of course, the textbook questions typically are harder or more, definitely worded more complicated than my typical test questions, but these are still useful for studying purposes. So for example, I have 107 and 108, 55 to 95. Some of those questions I'm going to tell you to skip. Once I get there, I'll tell you. Plus on the Google Classroom, I probably already typed which ones I would skip anyway. The questions I have on the smartboard, some of them are going to be straight from the textbook, while some of them I made up to show a specific scenario to make sure we practice that scenario. Okay, my recording failed earlier, so I kind of already did some of this. But let me just talk about it again. So the first one, what makes a function? What makes a function, it doesn't fail the vertical line test. So you can see this one, the red line hits the black one twice. And even if it fails the vertical line test a little bit. So like this is okay, over here is okay, but right here in the middle, it fails. So this red cubic-esque graph right here, it fails. So you can't pass the vertical line test, you are not a function. Now, how do you tell from an equation? So for an equation, it's very simple. If you have an absolute value of y or a y squared or a y fourth or yada, yada, an even power, that automatically makes it not a function. Which means the first one, the y is by itself here. Because the y is by itself, it is a function. While over here, while the x is by itself, the y is inside an absolute value. So that automatically makes it not a function. It's really that easy to tell from just looking at the equation. That's 3 points, don't lose them. Next one, finding zeros. So finding zeros here. On the first one, I factored it. I don't want to go over practicing factoring. What multiplies 11 adds to 10, 11, negative 1. And then you just do the math. You have x equals negative 11 and x equals plus 1. What's more interesting is this fraction one. So this is a fraction one. So when you do the fraction one, you're going to handle the top by itself first and then do the bottom second. You're going to handle the top first and do the bottom second. So to handle the top, I'm going to check what the zeros are. So here, 0 equals x squared plus 15x plus 36. So it's going to be x plus 12, x plus 3, because I multiplied with 36, I add to 15. So my two answers is x equals negative 12, x equals negative 3. I would love to say we're done there, but you have to do this, which is a check over here. You have to check the bottom. Now remember, the bottom of a fraction can never be 0. So you need to check very quickly, does any of these numbers here cause the bottom to be 0? Some of you already know, but just to plug it in, let's say if I didn't know, 12, 2 times negative 12 plus 6, that's negative 24 plus 6. That's not 0, so it's okay. But here, 2 times negative 3 plus 6, negative 6 plus 6, that does cause it to be 0. Because that causes it to be 0, even though the top would be a normal 0, this cannot be your answer. So in this case, for the second question here, the only answer you have is x equals negative 12. The only answer you could use is x equals negative 12 because negative 3 does not pass the test. So you use the top and find the zeros normally. Then you use the bottom to check if it's okay. If it's not okay, then you just stop right there. Okay. So this one, they give it in the textbook as an equation that you're supposed to put in a calculator. I'm probably just going to give you the graph. So this is the graph from the calculator. And we're going to talk about when is it increasing, decreasing, or 0, or constant, which means decreasing, increasing, or constant. That means I'm going from left to right. So if I'm going to left to right, am I going down a hill, up a hill, or staying on a flat road? Remember, you can't go straight down. If you go straight down, that must mean you're not a function. So straight down is not an option in this case. So first off, from here to here, it clearly looks like I'm going down at this point. So from here to here, I'm going down. And I go down all the way to negative 1, x equals negative 1. So I'm going to say I'm decreasing from x is less than -1. I am decreasing whenever x value is less than -1, which is all this over here. Over here to here, from -1 to what seems to be 0. From here to here, I have a flat surface. So I am constant between -1 and 0. So -1, which is less than x, which is less than 0. I am in between -1 and 0. It is a flat line. No increase, no decrease. It's a constant growth. Increase over here from 0 to infinity. So I am increasing anytime I'm past 0. So when x is greater than 0, by the way, I'm sure somebody's going to ask, can I write it as 0 is less than x? That's totally fine. Doesn't matter which way you write it. X is greater than 0. That means anytime you're bigger than 0, you're increasing. So on the test, I think we're just going to give you a graph and you're going to tell us is increasing, decreasing, constant versus doing the thing. All right, max and min is calculator. I'll do that in a separate video so I can set it up so the calculator can actually show on my screen. Next one is the average rate of change. I think this is number 65, I'm guessing. Yeah. So the average rate of change, you need to use this formula. This formula is not a new formula to you. This is the slope formula. We're just using function notation. So we're saying what is the value at x2, which is basically y2, and the f value at x1, which is y1. So before I start, I want to figure out what is the value at x2, and x2 in this case is 4. So I'm going to take the equation over here, which is the question from 65, and plug in a 4. So -4 squared. Now remember, it should be like this. 4 squared is in the square root, then the negatives on the outside. Plus 8 times 4 minus 4 equals, I don't know yet. -4 squared is going to be 16, but it's a -16. Plus 8 times 4, 8, 16, 32. Minus 4, which means it is 12. So f of 4, which is, by the way, the same thing as saying f of x sub 2 equals 12. So I finished the first part, which is 12 over here. Next, I'm going to plug in 0 into this equation. Plug 0 into this equation, but that should be pretty easy. The little whiteboard things there. So -0 squared plus 8 times 0 minus 4 equals, what's going to end up, this cancels out, this cancels out, -4, which means f of 0, by the way, is the same as f of x sub 1 equals -4. So I'm going to put a minus -4 on top here. On the bottom, I just plug in x2, which is 4, minus plugging in the x1, which is 0. 12 plus 4 is going to be 16 over 4. 16 over 4, your final answer is 4. Yep. So basically plug in your points and then solve the slope. Very straightforward. Okay, even at odd or neither functions. I talked about this at length in class. I'm just going to mention it very quickly. If f of x matches the same as f negative x, that means it's even. If f of x matches the same thing as a negative version of f of x, that means it's odd. So I'm going to show you an example with me using number 67. So f of x is what I'm given here. What I need to check if it's even, odd, or neither. It'll be even if I plug in an f of negative x and it is exactly the same as the original. So negative x to the 4th minus 20 negative x to the 2nd. Well, negative x to the 4th is a positive x to the 4th. And negative x squared is a positive x squared, so it stays negative 20x squared. And you check, does this new function match my original? Yes, it does match my original, so that's even. The question is, but Mr. Tobel, how do we check if it's odd? I'm going to make a quick one that's an odd. So f of x equals, I'm going to be lazy, x cubed minus 2x. Okay, so this one is going to be odd, and I'm going to tell you how you test that. You're going to first plug in f of negative x. I'm sorry, it should be f of negative x equals negative f of x. That should technically be right. Oh, wait, no, it doesn't. I don't know what I'm saying. So I'm going to plug in f of negative x. So that's going to be negative x to the third minus 2x. I'm sorry, not 2x, but negative x to the third minus 2 times negative x. So that's going to be negative to the third. It's a negative, negative, negative. So that's an odd amount of negatives. So it stays negative. Plus negative 2 times negative x is plus 2x. So first you check, does this match the original? No, it does not match the original. But before we call it over, we're going to check by taking out a -1. We're going to factor out a -1 and divide everything by a -1, which causes it to be a positive x cubed minus 2x. Now, does this match our odd function? Does this inside the square and inside the parentheses match our original? Yep, so that's odd, okay? Now, if it fails both tests, so it doesn't match here and it doesn't match here, you could write neither. Okay, this is literally algebra 1. It's too simple. I almost kind of want to skip it, but I won't. So this is right, a linear function number 69. As function values and sketch of the graph. You could just use your calculator to sketch it if you really want. But either way, to write the linear function, I want to make it, usually we like y equals mx plus b. The only slight difference, we're going to have it as f of x equals mx plus 3 at the end result, but it doesn't really matter. So how do we do this? First, I'm going to rewrite this as 2 comma negative 6. The 2 is the x value. The 1 by itself is the y value. So 2 comma negative 6. And this one is -1 comma 3. So we're going to find the slope. If you don't remember the slope, y2 minus y1 over x2 minus x1. So y2 is 3 minus -6. Again, I kind of don't want to spend time doing this, but it's the right thing to do. Minus 2. -1 minus 2. Again, we're just finding slopes. So that's 9 over -3, which reduces to -3 is my m. Because -3 is my m, I'm going to plug it into m over here. I'm going to pick one of the coordinate points. I'll pick this one. If you pick the other one, you'll still get the correct answer. It doesn't matter. So it's going to be -6 equals -3 times 2 plus b. -6 plus b, -6. Is it -6 really? Yeah. Plus -6 on both sides, or plus 6 on both sides. They both happen to cancel out. So 0 equals b, which means your final equation is f of x equals what your slope is, which in this case was -3 x. You would do plus b here, but because you have 0, you won't write the plus b, so you could stop right there. If you had like 2, you would do plus 2 there, but it's just -x, -3x. Again, this is literally algebra 1. I'm literally testing on my algebra 1 Wednesday on this. So if you can't do it, you should be a little bit embarrassed, honestly. But you got it. Don't sweat it. Transforming into power functions, I'll also do that on the calculator video. All right, function combinations. So function combinations. So in the test, this is question number, or in the review, this is question number 85. And they ask you to do f plus g, f minus g, f times g. Notice this is a solid circle, and f divided by g. Of x. I think they're all of x. Let me just check real quick. Yep, and they ask you the domain, you don't have to worry about the domain part. So first off, when you do f plus g, you're just combining like terms. So x squared plus 3 plus 2x minus 1. That final result will be x squared plus 2x minus 2. No, plus 2, my bad. So you just add them if you have an adding. If you're subtracting them, well, hello, you just subtract it. X squared plus 3 minus 2x minus 1 equals x squared minus 2x, because there's nothing in front, so it's a negative 2x. And then 3 minus negative 1 is going to be plus 1, so 3 plus 4. Okay. F times G, you're going to have to actually FOIL here, or distribute. 2x minus 1. FOILing quickly, 2x cubed minus x squared plus 6x. You can always pause the video if you can't keep up. Minus 3. Yeah. And then that's all the like terms. Pretty straightforward. Nothing special there. You can't combine any like terms. If you could combine like terms, please do. But this is x cubed, x squared, x and negative 3. You can't combine. This one is just set up as a fraction. You do want to check if you could simplify something like we did 2 tests ago. But this one, they're not going to typically have anything to simplify. You're good to go. Nor I'm going to really put one to simplify. We test that all 1 or 2 tests ago, so you don't need to do it again. So you just put it as a fraction, nothing you could do. That's why they ask you for the domain. I don't even care for the domain. But no, I don't care about the domain. All right, next one's composite functions. Composite functions is a function in a function. Let me see if they ask anything else. This is number, I guess if the last one's 85, this should be number 87. Yeah. If this was 85, this one's 87. And they ask for the domain. You don't have to give me the domain, actually. But still. All right, f of x, g of x. So we're going to do f o g, or f of g of x. And we're going to also do g o x of x. And I'm going to throw in a third one, f o g of, let's do 3. Okay. So first, let's do f of g of x. So that's f of g of x. So in this situation, all I'm doing is substituting g of x for what is actually equal to, which is over here in green. So we have equals f 3x plus 1. Now I'm going to take this value right here. I guess I'll use blue. This value right here and plug it into the x over here. So then, because this f of 3x plus 1 is going to go in for every x in the f of x equation. So 1/3 3x plus 1 minus 3. I guess I'll rewrite this as 1/3 x minus 3. So you see a little more clear. Okay, let's distribute the 1/3. We're going to get 1/3 times 3 is just x. 1/3 times 1 is plus 1/3 minus 3. You could change it to decimal if you're so afraid of fractions, but you should be able to handle that. 1/3 minus 3 is going to be is going to be negative 2 and 2/3. Again, if you want to change that to decimal because you're afraid of fractions, totally fine. Okay, that's the first one. The second one, we're going to do g of f of x, so slightly different. This is not commutative like normal multiplication is. So I'm going to replace the g of x, or the f of x, I'll use a different color, the f of x with this equation right here. So it's going to be g of 1/3 x minus 3. So then I'm going to take 1/3 x minus 3 and plug it into here. So I'm going to take this equation and plug it into the g of x. So it's going to be 3 1/3 x minus or plus 1 minus 3. So I'm going to distribute a 3. 3 and 1/3 is x. 3 times 1 is 3, so plus 3. Then you have a minus 3. Did I mess up? I did mess up. This is not, this is 3, 1/3 x minus 3. I'm supposed to put, I mixed up the situation. This should be minus 3 in here, and this should be the plus 1. My fault on that. So distribute again. 3 times the third x is just x. 3 times 3 is -9. That's more like it. Plus 1. X minus 8. So notice how you have different answers depending if you're doing g of f or f of g. All right, the next question we're going to do is f of g of 3. This is not in your textbook, but this is something I would give you. So that means I'm going to do the f of g of 3. So the first thing before I even start this problem is I'm going to find what g of 3 is. How I'm going to find g of 3? I'm going to plug in 3 for every x in the equation. So 3 times 3 plus 1, which means g of 3 is 10. So from here, I'm going to replace g of 3 with 10. Now I have f of 10. I'm basically do the same thing. Take the 10 over here and plug it into every one over here. So 1/3 times 10 minus 3. Okay. 1/3 times 10 is 10/3. Or I'll do 3 and 1/3. Minus 3, which means my end result, 3 and 1/3 minus 3, that's going to be just 1/3. So when you have a number here, your final result should be number. If you have an x or a variable here, your final answer should be something involving an x or whatever variable it is. Okay, find the inverse function of this thing. So we're going to find the inverse function. So f of x equals 3x plus 8. The steps to find the inverse function, I wrote it as notes. You better have it. First, make your f of x into a y. So y equals 3x plus 8. Then swap your x and y. X equals 3y plus 8. Now solve for y. So I'm going to subtract 8 on both sides. So x minus 8 equals 3y. Divided by 3, divided by 3. Y equals x minus 8 over 3. So your inverse function, and how we write inverse function, is f of -1. Notice the -1 is on the f itself and not on the x. Is x minus 8 over 3. Make sure you finish it off by putting the f of -1 to indicate this is your inverse function. Again, box your answers makes it easier for me to see what you actually answer versus what you don't answer. Yep, that's how easy it is to find the inverse. And then I'm going to give you a type of problem. This is not in the textbook, but how to test if something's an inverse. How to test if something's an inverse is that if you do f o g or f of g of x, your result should be an x. Just an x, just the variable x. So let's see if that happens. Also, I'm sorry, and then you have to do g of f of x and see that also results in an x. So if you do a composite function, which is the function in the function, they should both be just x. So I'm going to do the first one here. F of g of x which means I'm going to replace this g of x with what it is. So f of cube root x plus 1, because g of x became cube plus 1. Now I'm going to plug it in here. So it's going to be x. This x right here is going to become cube root x plus 1. So let me just fix this up a little bit. To make it less confusing, I'll use a different color. Cube root of x plus 1 minus 1 cubed. So the red is what I plugged in for the x. 1 and negative 1 cancels out. So you're left with cube root of x cubed. A cube and the cube root cancel out. That equals x. So first part checked off. We're good. We got to do it in the reverse now. G of f of x, which is same as g of the f of x, which is x minus 1 cubed. Which means I'm going to substitute this in. Again, I'll try to use a different color. The cube root of x minus 1 cubed plus 1. Because it's x minus 1 cubed, the cube and the cube root cancels out. So it's just x minus 1 plus 1. X minus 1 plus 1 results in just an x. So that checks out. Because they both check out, these are inverses. So yes, the question is yes or no, is it inverse? Yes, it is an inverse. Of course, you're going to actually have to show me your work for credit on this one. You can't just give me the 50-50. Yeah, Mr. Tobel wouldn't give us a non-inverse, or Mr. Tobel wouldn't mess with us. So you can't expect that. You got to give me the work. I will make a separate video. I don't know if I can make it today, honestly, but for the transformations. But I feel like we did a lot of practice of transformations. That was pretty simple. And the max and min, we got to use the calculator for that. But overall, this will be user useful. Again, on the Google Classroom, hopefully that helps. Good luck on your test. Don't worry about it too much. It's a lot of little things, but most of these things are like old stuff, algebra 1-ish stuff, or like pretty straightforward, like nothing too tricky.